Hi, so today I'm going to share my approach of this question monk and rotation, which is a question from Code Monk series, which is from HackerEarth. So in this question, as you see, the problem statement says that it is nothing like very complicated. We just have to rotate the array like k times. Okay, so this is the sample input. This is the size of the array like 5, and this is the k. So we have to rotate the array for k times. So let me show you quickly like what is rotation and how to rotate the array. So suppose this is our example array like 1, 2, 3, 4, and 5. Okay, so suppose k is 1. Okay, so we have to rotate this array like one time. So how we will rotate this array and what exactly means by rotation? Okay, so it is simply nothing, just we have to put the last element in front of the array and change the array according to this. Okay, so our new array becomes this 5. Then we put the last element to the front and rest of the elements will remain same. Okay, so 5, 1, 2, then 3, then 4. Then we stop after that because we have removed this from the back and put it in the front. So yes, rotation is just exactly like that. And let me see another example. What if we want to rotate for 2 times? So this is our first rotation. Let me say call it as A1. Okay, what will be our A2? So A2 will be nothing special. We just have to put the last element to the front before 5, and rest of the elements will remain same. And also, like, of course, we do not have to duplicate any element. Like it will be like 4, then 5, then 1, then 2, then 3. After 3, we won't put 4. We won't duplicate 4. We just have to like put the last element to the front. So by rotation, I hope you get the basic idea what is rotation and how to rotate the array like k times. So in the problem statement, it is nothing but we just have to rotate the array k times. So one of the basic problems or like a cache arises, like what if k is 6? Let me put k as 6. So this is yes, this is the first rotate array. Like if we rotate the array like for the first time, then our array becomes like this. For the second time, sorry, let me put it A2. For the second time, if we rotate this original array like 2 times, it becomes like this. Let me put A3 and A4 also. A3 will be 3, 4, 5, 1, 2. And likewise, A4 will become like we just have to put the last this element on the front. So it will become 2, then 3, then 4, then 5, then 1. This is our A4, like fourth rotation of the original array. Then A5 will become, we just have to put last element like that is 1 to the front. Okay, and rest will be same. 1, 2, 3, 4, 5, and A6. Let me put A6 also. A6 will be 5, 1, 2, 3, 4. So here you can see one important thing about the question is while rotating the array like 5th time. So we come across like the original array. As you can see that this was like 1, 2, 3, 4, 5. If we rotate any array for n times, like whatever is the size of the array, let me put n also. Let us say size of the array is n, which is 5. So whenever we rotate any array for n times, like for the size times, whatever the size of the array, whatever the number of the elements in the array is, so whenever we rotate any array like 5 times, then that array becomes like the original array. So I have shown you through the example also, like rotation 1 2 3 4 5 5, yes. After on the by the fifth rotation it becomes like the original array. So after that the sixth rotation is like this: 5 1 2 3 4. Sixth rotation is exactly similar to the first rotation, because we are just putting the last element to the front on the original array for the one time. So from this understanding we can make or simplify our problem. We can take a we can use a modulo operator. Okay, modulo operator is nothing. Let me explain that also. Modulo operator is nothing like, if we take any like number a modulus b, we do nothing. We just divide a. Yeah, so I was saying that we have to divide a by b. Okay, and whatever the remainder we get, that becomes our answer. Let's suppose we put in this question we can use a modulus n. Okay, so that we don't have to go all around these rotations, like these rotations are unnecessary. We can just rotate this original array for the first time. Okay, and then we can get the sixth rotation. So what will be the k modulus n? Our case k is 6. Okay, 6, and n is obviously 5. So 6 modulus 5 will be 1. If we divide 6 by 5, okay, so the remainder will be 1. Like 5 ones are 5 and remainder will be 1. Okay, so k modulus n will be 1. So if we rotate this array by k modulus n times, then obviously we can get our rotated array. So we can put k as like several times, like hundreds or thousand or whatever we want. Then we will get our this final thing. Okay, so let me show you on the code also. So my simple approach is that first we will put the second part of the array, then the first part of the array. So because we have to rotate, let's suppose we have to rotate for 2 times. Okay, so this we don't need. Let me put it below. Suppose a equals to b, and array will be same. So what we do, we just put 5. First rotation will be, let me just copy that, 5 1 2 3 4. Okay, and the second rotation will be 4 5 1 2 3. Okay, so in this question we can see that we want this as the final result: 4 5 then 1 2 3. So what we can do, we can divide this array in 2 parts. Not exactly, but we can use any pointer and we can divide this array into 2 parts. Let me see if the recording is going. Yeah, so we will divide this array into 2 parts, and we can just create a new array. Okay, first we will push these 2 elements 4 5, and after that we can push these remaining 3 elements 1 2 3, and automatically we can get the rotated array. Okay, so our first rotation will start first part of this thing will start from 4 5. So how we will get 4 5? We can easily get 4 5 using n minus k, which will be 5 5 minus 2, which will be 3. So index is like obviously 0 base. So 0, 1, 2, 3. So we can start from this n minus k till n. So I'm writing this. Start from n minus k and go till n. Loop runs less than n, so we can say that n minus 1. Okay, nothing complicated. Loop we terminate like less than 1. Either if you're using less than 1, then we can take n, or if you're using less than or equal to, then we can take n minus 1. Okay, so we will loop from n minus k to n, or less than n, that is n minus 1. Okay, so we will get this first part 4 5. And what about the second part? Second part is simple. We can go from 0 to n minus k, that is less than n minus k, that is n minus k minus 1. So for the second part, start from n minus k minus 1. Why minus 1? Because n minus k n minus kth element is already being handled. That fourth element is already being handled in the first part 4 5. So we will we will start from 0. Yeah, we will start from 0, that is first element, and go till n minus k minus 1. Okay, so we will use two loops. We can use any empty array like answer array for our answer, and push the elements according to these two loops, and after that we will print that array to get the answer. Okay, so let me go to the this thing terminal. Okay, so a will be a modulus n. In that way we don't have like we can definitely decrease the number of loops or function calls in our question. So it will be very much easier to solve this for the compiler. And for the first part, where is this? For the first part, we will loop from this n minus k, n minus 1. Okay. So let me take an string also, and we can directly get the answer for that. Okay. So this is for the second part, because we have to rotate now. We have to, these two in the front. So from n minus k to n, like less than n. Okay. Answer will be answer plus array. Is this array? Yeah, array of I. Plus we can put a space bar. So our first part is finished. And after that, either we can check by consoling. I think it would not be a good idea. So let me just finish the whole thing. So n minus k to n is already being handled. Not n, yes, n minus 1. Okay. So we'll start from 0 to n minus k minus 1. It looks like a little bit confusing. Let me write the easier way. Answer plus equals to this. Okay. After that, we can just console or print the answer. Okay. So let me try to compile and submit this. Okay, the sample test cases has passed. So let me submit this code. Let's see what happens. It is evaluating. As you can see, this is accepted. So that is it. So the basic thing to understand is that we just have to use this thing, k modulus n. Okay, so that we can, what if the k is 1,000 or in million, so we cannot like loop it like million times. It will be like waste. It will be a complete waste. Okay, so this thing is one thing, important thing, k modulus n. And another thing is breaking the array in two parts. Okay, first part we will loop from n minus k to n minus 1. Okay, the second half or second part of the array. Okay, and after that we can push or add to the string the first half of the array from 0 to n minus k n minus 1, and after that we can console our answer. So that's it. Thank you. If you have any comment or suggestion, you can comment down. Thanks for watching this video.